High-intensity discharge lamps include mercury, metal halide, and sodium lamps. They produce light from an electric arc between tungsten electrodes housed inside a fused quartz or high melting point glass tube. This tube contains both an inert gas, usually argon, and metal salts. An electronic or magnetic ballast usually generates a high voltage that ionizes the inert gas. This starts the electric arc, heats the inner tube, and vaporizes the metal salts to produce a light-emitting plasma. Once the plasma forms, the ballast sustains the arc at a low, steady current. Mercury lamps emit light that is rich in the ultraviolet and blue wavelengths. This casts a ghostly pall over the illuminated area, as well as requires UV filters in the outer glass envelope to minimize dangerous radiation. Metal halide lamps add other chemicals to the mercury, such as sodium iodide and scandium iodide, that broaden the spectral distribution of light emitted, giving it the appearance of natural daylight. These lamps provide illumination for night sporting events. Low-pressure sodium lamps emit nearly pure yellow light. High-pressure sodium lamps also contain mercury, and the blue light from the mercury, in addition to the accentuation of minor wavelengths from sodium under pressure, gives these bulbs a whiter appearance. High-intensity discharge lamps are relatively expensive, about $150 to $250 per unit that includes a fixture, ballast, and bulb. Prices do not vary much with size, from 70 watts to 400 watts, and so most installations have a few large units rather than many small units. High-intensity discharge bulbs account for only 1.2% of global lamp sales, but they deliver 29% of the electric light because they have higher efficacy, higher average power, and longer lifetimes than most other lighting sources. Their high purchase price, large size, and hot bulbs make it unlikely, however, that high-intensity discharge bulbs will penetrate further into residential lighting markets, except in closet greenhouses.